Hello my dear COMEDK aspirants, how are you all? I hope you all are doing amazing. This is your Ekta ma'am here. So my dear students, what I will be covering in this video is the top 15 most repeated questions from the chapter solutions. Yes, from this chapter, the questions that gets repeated every year, maybe not the same data, but what we get, the same kind of concepts, the same kind of formulas that are being used in these kind of questions. Okay, so we'll be solving all these questions, okay, for your COMEDK. Okay, now let's begin with our first question. Okay, I want you to do one thing when you are watching this video. Please solve the questions alongside me so that you know where you stand. Okay, and maybe it will be a little revision for us, right? A little revision session. So in this question, 25 ml of 0.08 normal HCl neutralizes 20 ml of NaOH. So what data is given here? We are given N1, which is the normality of HCl, which is 0.08 N. The volume of HCl is already also given, which is 25 ml. Okay, now normality of NaOH, is it given? No, it's not given. Okay, so it is the unknown quantity. Okay, and the volume of NaOH is also given, which is 20 ml. Now we know how these normalities are related. See, this amount of HCl is neutralizing 20 ml of NaOH. Okay, we don't know the normality, but this amount of HCl is neutralizing this amount of NaOH. So that means their concentrations are same. That means here N1V1 equals to N2V2. We know all the data, only N2 is unknown. So if we calculate it, it will come out to be 0.08 times 25 equals to N2 times 20. The answer will be around 0.1 normal. That is the normality of NaOH solution. That is the normality of this NaOH solution. The question asks the mass of NaOH that is present in 5 decimeter cube. Okay, now decimeter cube, don't get confused. Decimeter cube is same as liter. Decimeter cube is same as liter. So in place of this, I can also write 5 liter. Okay, now what is this? This is the volume. Volume is given. For this volume, you need to find the mass of sodium hydroxide. For this volume, you need to find the mass of sodium hydroxide. Okay, now let's see. This is the normality. This is the normality, this is mass, volume. How do we relate all that? So my dear students, there is one more thing. There's a relation between normality and molarity. What is that relation? Yes, correct. Normality equals to molarity times N factor. Molarity times N factor. Okay, N factor could be the number of replaceable hydrogen ions, number of replaceable OH negative ions. In case of sodium hydroxide, it is 1 because it has only one replaceable OH negative ion. Okay, so that means for NaOH, normality is equals to molarity. So what is the molarity? Then the molarity is 0.1 molar. Okay, I hope it is clear till now. Okay, now we need the mass. What do we need? We need the mass. Let me see. So we have 0.1, which is equals to molarity, is number of moles of solute present in 1 liter of solution. Volume is already given to us. What is the volume? It is 5 liter. Okay, number of moles. Number of moles is what? Given mass upon molar mass. Now that mass we need to figure out. What is the molar mass? Molar mass will be your 23, 16 plus 4, which is 20, 43. Okay, the molar mass is 43. So 0.1 equals to 20, yes, 1, sorry, 9, 1, 10, 40, yeah. So that is equals to number given mass. Let's say that mass is W by 40 times 5. And now the volume is already in liter. You don't need to convert anything. Okay, now let's just calculate it. It will come out to be what? 5 times 4, 20. 20 gram. Okay, this comes out to be 20 gram. That is the amount, that is the mass of NaOH that is present in this much 5 liter. Okay, how did we calculate it? Quick recap here. N1 given, V1 given, N2 is we need to find, V2 is already given. We know N1 V1 equals to N2 V2. From here we found out the normality. For this case, for NaOH, number of replaceable OH negative ion is 1, and normality and molarity are related like this. That means molarity will be 0.1 m. Now if molarity is given, then what do we talk about here? We'll talk about molarity is equals to number of moles of solute dissolved in 1 liter of solution, right? Number of moles is given mass upon molar mass, given mass upon molar mass, and volume is already given 5 liter, right? So weight comes out to be 20 gram. Little concepts are being used, right? Yes. Next question. Henry's law constant is given. So we are given Henry's law constant, which is 4.27 times 10 raised to power 5 mm Hg. Clear? The mole fraction we need to find when the pressure is already given. Pressure is also given 760 mm Hg. One more thing we need to know, what is a Henry law? So Henry law concerns itself with the dissolution of gases in liquids. So when we are talking about solubility of gases in liquid, we talk about Henry's law. Okay, now according to Henry law, the amount of gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas present above the liquid, right? Partial pressure of that gas that is in equilibrium with the liquid that is present above the liquid. Okay. So here, how do you write the Henry's law? P will be equals to KH times the mole fraction of which here in this case methane. Okay, mole fraction of methane, because we are trying to dissolve methane in benzene. Okay, this value is known, this value is already known, 760 equals to 4.27 times 10 raised to power 5 times mole fraction of methane. So that mole fraction of methane will be equals to 760 by 4.27 times 10 raised to power 5. Yes, 5. Okay, then mole fraction of methane will be equal to what? 1.78. Yeah, it will come out to be 1.78 times 10 raised to power minus 3. This is the required answer. Okay, I hope you were able to get the answer. Very simple logic. All the constants are given. KH is already given. Partial pressure is already given, right? We need to find the mole fraction of methane. Next question. When this much amount of non-volatile solute is dissolved in 100 gram of benzene, it raises the boiling point, right? That means elevation in boiling point is happening. How much elevation is there? 1 degree Celsius. You need to find the molecular mass of this non-volatile solute. So what do we know? We know that elevation in boiling point is equals to Kb into m. M is the molarity, right? That's how you calculate the elevation in boiling point. This is given, del Tb is equals to 1 degree Celsius. Kb is already given. Kb is what? 2.53 Kelvin kilogram per mole. Okay. M, molality. What is molality? Number of moles of solute present in 1 kilogram of solvent. Number of moles of solute present in 1 kilogram of solvent. What are the number of moles of solute? The solute is what? 10 gram. The molecular weight, we don't know. Let's say it is ms, molecular weight, we don't know that. Okay. Times the amount of solvent is 100 gram. You will convert it into kilogram. Okay, now simply you substitute this, all three values here and calculate for ms. Okay, so I'll substitute here 1 equals to 2.53 times 10 times 1000 by ms times 100. Okay, if you calculate it, if I'm not wrong, these will get cancelled. Okay, and the answer will be, the molecular weight will be 253 gram. The molecular weight of the solute is 253 gram. I hope you get the answer D, right? You see, straightforward questions are there. Okay, up till now we haven't faced much of a difficulty yet, right? And this is the last year questions. Okay. If an equimolar solution of calcium chloride and aluminum chloride is in water have boiling point T1 and T2, what will be the relation between T1 and T2? So now see, equimolar, that means the molarity is same. M is same. So what will be the factor here? What will be the factor here for boiling points? The factor will be Van Hoff factor. Van Hoff factor. That is your I. Okay, for both of these, if the molarity is same, we know that one more relation is there, right? Delta TB equals to I KB M. If rest of these values are same, then the relation is directly related to your I. I is Van Hoff factor. It is related to both association and dissociation. In this case, we are dealing with dissociation. What are we dealing with? Dissociation. As calcium chloride calcium chloride dissociate as calcium Ca2 positive and 2Cl negative. So what is the number of what is the amount of solute here? 2 plus 1 3. So that means the Van 't Hoff factor is 3, right? Similarly, AlCl3, it gives Al3 positive plus 3Cl negative. What is the Van 't Hoff factor for it? 3Cl and 1 Al, right? 1 aluminum and 3 chloride ions. Okay, so the number of solute is 4 here. 4 here. Now you can see, if we are talking about temperature T1 is related to CaCl2, temperature T2 is related to AlCl3, the relation is direct. These are directly proportional. More the Van 't Hoff factor value, more will be the elevation in boiling point, or more will be the boiling point here. Okay, more the Van 't Hoff factor, more will be the boiling point. Okay, so which has more higher Van 't Hoff factor? This one, right? T2, right? So that means T2 will be greater than T1. T2 will be greater than T1. That is your correct answer. Okay, clear? Yes, I hope you get your answer. Now, moving on to the next question. We are talking about osmotic pressure here. Now, what is the relation for osmotic pressure? Relation is simple. Pi equals to CRT. C is concentration. Now, remember, concentration can be molarity. It can be molarity and it can be molality also, depending on the data that we are given. Okay, it can be molality and it can be molarity, right? So it contains a non-volatile solute whose molecular mass is Mb. Okay, which of the following can be used to calculate the molecular mass of the solute in terms of osmotic pressure? Now let's rewrite this expression a little bit. Let's say here volume is given. We are talking about volume and mass. Mass and volume. Does it click something? Yes. That means we are talking about molarity here. What are we talking about? Molarity here. Now what is molarity? Number of moles of solute. What is number of moles of solute? Which is the amount of solute, mass of solute given upon the molecular weight of solute, times okay, volume times volume. Now there is no 1000 here, so we are considering it in liter only. Okay, that is your concentration, times R times T. What do we need? We need this. We need this only. So we will take it left hand side and put all the data on your right hand side. So MB will come out to be, solve with me, WB by pi V times RT. Okay, which is the closest one to this? WB RT by pi V. That means option B is your correct answer. Okay, next question. The increasing order of freezing point. Okay, again, freezing point, increasing order. Okay, increasing order. Let's just clear one thing. That means freezing point is increasing, right? So that means what is happening here? Low depression in freezing point. We are talking about low depression. The lower the depression, higher will be the freezing point. Lower will be the depression. It's opposite for minus degrees, right? So the lower is the depression, higher is the what? Higher is the freezing point. So here let's check. That means this increasing order is inversely proportional to I. Because we know that depression in freezing point is directly related to Van 't Hoff factor, because it's a colligative property. More the number of solute, more will be the depression in freezing point. That means if more is I, more will be depression, but we are talking about least depression, low depression, right? So that means lesser the number of solute, low will be the depression. Okay, so it's like opposite. Okay, you'll understand when we solve the question. For this, I'm just writing the Van 't Hoff factor value for ethanol. It does not dissociate. It's 1. Okay. For this, it will give 3Ba2 positive and 2PO4 3 negative. So that is 3 plus 2 means 5. Okay. Na2SO4 2 Na positive, SO4 2 negative, 3. Okay. For KCl again 2. For Li3PO4 it gives 3 Li positive and PO4 3 negative. PO4 3 negative. Clear? Yes, that means there are 4. Okay, 1 2 3 4 5. 1 2 3 4 5. Done. Okay, highest I values of what? This one, 5, right? 5. So that means this will have the this will have the least boiling point. Sorry, least freezing point. This will have the, hold on a second. This will have the least freezing point actually. Least freezing point, okay, and we are looking for the increasing order of freezing point, least to highest value, okay. You know that -10 is smaller than -2, -10 is smaller than -2, okay. So this will have the least one. Now which is the option which have this as least? Either option A, option B, or option D, okay. Now which will have the highest increasing order? No, so which will have the highest freezing point? The one with the least I value, least Van Hoff factor value, right? That is C2H5OH. Here I see only one answer, which is D. So that means this is incorrect, this is incorrect, okay. This is incorrect, this is incorrect, and your correct answer is option D. Correct answer is option D. And even if you go by that, this has 5, this has 5, okay. Now this has how many? 4. This has 3, this has 2, and this has 1, okay. So it is the, again, in the decreasing order of I values or increasing order of freezing point, okay. Read the question, okay. Maybe you think, oh, I is directly proportional because they're talking about depression freezing point, but the question is little different, right? The language is a little different. 0.5 m of sulfuric acid is diluted from 1 liter to 10 liter. Molarity of the resulting solution is, okay. Now see, the initial molarity is 0.5 m, okay, and initial volume is also 1 liter. Final volume is how much? Let's say final volume is V2, which is 10 liter. The resulting molarity M2 we need. We know these molarities are related in one way. If you, so it's like that equilibrium thing, right? Balancing. If you increase the volume, the molarity will decrease, because overall this factor should remain constant. This factor should remain constant, okay. So, and also one more relation is there, M1V1 will be equal to M2V2, right? Because again this factor needs to be same. M1V1 will be equals to M2V2. M1 is what? 0.5 times V1 is 1 equals to M2 we need to find, and V2 is times 10. So M2 is equals to what? Yes, 5 by 100, 1 by 20, or 0.05. Yes, 0.05. That means option D is your correct answer, okay. Now before, yes, so we have, just a minute, can you give me? Yes, before that we have this one question. The diagram which is given below, it is a diagram for binary solution of A and B, okay. If it's not visible, I'll just clearly draw it here. So this is like this. Here we have vapor pressure on the y-axis, and here we have the mole fraction of B, right? When we are going from A to B, what is happening here? This graph is slightly slanted upwards, okay. Okay, you need to tell me, is it showing positive deviation, negative deviation? What kind of interactions are there actually? So as you can see, ideally it should have been like this. Ideally, it should have been like this, okay. I'll just draw it straight away. Yep, ideally it should have been like this, but it is slightly upward, right? What kind of thing is that? That means the pressure, the total pressure of A and B, of the mixture of A and B, is greater than the partial pressure of A, greater than the sum of partial pressure of A and partial pressure of B. See, right? That means what is happening here? What is that kind of interaction? If high partial pressure is there, if the total pressure is greater than the individual pressure, so we are having what? Positive deviation. When does positive deviation happens? When the AB, the forces of intermolecular forces between AB is lesser than AA and BB. they are lesser than AA and BB. So the answer is when the interaction, the AB interactions are lesser than AA and BB interaction. That is option C. Okay, just like this is directly related to vapor pressure. What happens here? So if you have one A solution, you have a B solution, and if you mix them or make a AB solution, supposedly that solution has weaker interactions. Weaker interactions means it will boil off rather easily, right? It will have a high vapor pressure than the AA and BB. That is your positive deviation. Why? Because the forces are not strong. So even little bit heating will get the vapors. Only on little bit heating will get the vapors. Why? Because the intermolecular forces are not strong. These show positive deviation from Raoult's law. These show positive deviation. Okay. Now, if these suddenly somehow you mixed A and B and the solution suddenly have low vapor pressure. Okay, suddenly have low vapor pressure. Why? Because the interaction between AB are so strong. Then if you heat it, the intermolecular forces are strong. You need to heat it to a higher temperature. You need to heat it to a higher temperature, right? The vapor pressure is low. That is negative deviation. Why? When does it happen? It happens when AB interactions are stronger than AA and BB interactions. AA and BB interaction, that it will show negative deviation. When the intermolecular forces between A and B are really stronger than AA and BB. Okay, solute and solvent interactions. Okay. Next, okay, before moving on to the next question, my dear students, we have launched a COMEDK 30 crash course. It's a 30 days crash course to get top rank in your COMEDK. Okay, so this course is starting from 6th of April. Okay, you will be getting all the complete revision for class 11th, 12th, 5 full-length mock tests will be given, daily live doubt solving classes with teachers. Yes, every day one doubt solving class will be there, and again you'll be getting lecture notes, daily practice problems and everything. All the details you'll get later on. Okay, you'll get all the details. Okay, it's starting from 6th of April. Okay, so if you want to get a really good rank, a top rank in COMEDK, you should consider joining this course. Okay, now back to our questions. You see, this is just a snippet of what we teach there in the crash course. It's a systematic way of studying. Okay, you don't need to rush around here and there. Everything is there. PU1 is there, PU2 is there, chapter wise PYQs are there, mock tests are there. Okay, and everything is scheduled. Somebody will schedule it for you. Everything is scheduled. Okay, every day you will be given that today is this topic you need to cover, and after 2 days you will be having a test of the same topic. Okay, so it's a systematic way of studying. Okay, if you're looking for that, this is for you. Now, next question. What will be the mole fraction of ethanol in a sample of spirit containing 85% ethanol by mass? One more thing, spirit has ethanol. If 85% is ethanol, if ETOH is ethanol, okay, if this is 85%, then rest 15% is water. Rest 15% is water. We need to find the mole fraction of ethanol. Okay, we need to find the mole fraction of ethanol. 85% by mass, that means 85 gram ethanol is present in 100 gram solution. 100 gram of solution. This is solution. Okay, you need to find the mole fraction. Okay, now let's see what data do we have here. Okay. Okay, now see, we need to find the mole fraction again. 85 of this 100 is there. The mole fraction, what is mole fraction? Mole fraction of ethanol is equals to the number of moles of ethanol by total moles, number of moles of ethanol plus number of moles of water. Okay, how much is the moles of ethanol? 85% means 85 gram. So 85 by molecular mass of ethanol 46 upon 85 by 46 plus 15%, which means 15 gram. If 85 gram of ethanol is present in 100 gram, how much amount of water is there? 15 gram. 15 gram is present in 85 gram of ethanol. Okay, this is how you calculate mole fraction, number of moles of ethanol by total moles. Okay, this is that's how you calculate it. And if you do the calculation, hold on a second, if you do this calculation, the mole fraction of ethanol will come out to be 0.69. 0.69. That is option A. Okay. Next question. What will be the degree of dissociation of this much M solution if Van 't Hoff factor is 2 0.74. A similar question was asked in 2025 also. A similar question. Okay. Now let's solve this question. We are asked the degree of dissociation, right? And what are we given? The molarity is given, which is 0.1 m. Okay, of this solution. Okay, and Van 't Hoff factor I value is also given, which is 2.74. Okay. If molarity is given, alpha is already given. Now alpha is being asked. Okay, so let's calculate it first. We know degree of dissociation is related to Van 't Hoff factor in what way? I minus 1 upon n minus 1. Now why did I use this? Because it's written dissociation. Dissociation. We have two things. When you calculate Van 't Hoff factor, you have two formulas. One is for dissociation, the other is for association. This one is used when dissociation is there. Okay, n is the total number of atoms. N is the total number of atoms. So in MgNO3 twice, you have Mg2 positive and 2 NO3 negative. 2 NO3 negative. That means n is 3. Three atoms you have. Okay, 2 of NO3 negative and 1 of Mg2 positive. Okay, so alpha will be equals to 2.74 minus 1 upon 3 minus 1. 3 minus 1. Okay, so 1.74 by 2, which is 0.87. Okay, now this is the alpha value. We need to convert it into percentage. How do we convert it into percentage? Multiply by 100. Multiply by 100. The answer will be 87%. The degree of dissociation is 87%. Yes. Okay. This question has been asked last year also. Okay, it's a very simple question. You just need the formula of if association is given or if dissociation is given, depending on this word. Okay. Next question. Calculate the freezing point of an aqueous solution containing 10% by mass of glucose, 5% by mass of urea, 1% by mass of KCl. Kf is already given. So firstly, it's a little lengthy question, calculation wise. Okay, concept wise, very simple. The depression in freezing point. You need to calculate the freezing point. We know the depression freezing point is Kf times molality. So we will calculate firstly molality. Kf is already given, and this delta Tf is equals to what? The freezing point of freezing point of water, not pure water. Okay, minus the freezing point of solution, because there is depression happening. This value is given. We need to find this value, the freezing point of an aqueous solution. Aqueous solution. Okay. It depends on your calculation, actually, how fast you can do it. Okay, so firstly, let's calculate the number of moles of all of these. Firstly, let's start with glucose. The number of moles of G. Glucose is 10% by mass. That means 10 gram of glucose is dissolved in 180. 10 gram of glucose is dissolved in this much solution. What is the molecular weight of glucose? 180, right? Okay. Second, urea. For urea also, the number of moles of urea will be 5 by 60. Okay, and for last one is your KCl. For KCl, the number of mole of KCl will be, let's say it is 1 by, how much is there? 1 by 74.5 something. Yeah, its answer is 74.5. But remember, we are talking about KCl. KCl will dissociate also. It will dissociate as K positive and Cl negative. K positive and Cl negative. So we won't be getting just one ion. What we will be getting? 2. So here, this much is the number of moles of KCl. Number of moles of KCl. Okay, I hope it is clear. Now, how much will be the total number of moles of all these solutes? What will be the total number of moles? So I'll just combine them. Ng plus Nu plus NKCl. Glucose, urea and KCl. Okay, so I don't want to write it again only. Okay, the answer will be 0.166. 0.166. I calculated it. Okay, now this is the number of moles, total number of moles. You need to calculate the molarity, right? So if you calculate the molarity, okay, that is the number of moles present in how much? Weight of solvent. How much is the solvent? 100. If we take total 100, then 10, 5, 16 is gone. 84 times 1000. That is your molality. That is our molality. Okay, and if you calculate it, it will come out around 1.97. Okay, it will come out around 1.97. This is your molality. Okay, after calculating the molality, if you substitute it here, okay, that is TF0 minus TFS equals to 1.97 times kb. kb is 1.86. The answer will be 3.67. Yeah, the answer is 3.67. Okay, now the pure solvent for pure water, it is 0. For pure water, the melting point, the freezing point is 0. Okay, so if I substitute 0 here, then this much I need na. We need the freezing point of aqueous solution. So the freezing point of aqueous solution is minus 3.67 degree Celsius. Minus 3.67 degrees Celsius. Okay, the one little tricky part was here that we are given 3 solutes. So we need to calculate the total number of moles, and if you calculate the total number of moles, by that you calculate the molality. Then you calculate molality, total number of moles dissolved in 1 kilogram of solvent. Okay, this much is our solvent. After putting the molality in this equation, molality times Kf, you get your depression in freezing point. We already know that for pure water the freezing point is 0 degrees Celsius, so that means for solution it will be 0 minus 3.67. okay, and that means the answer is minus 3.67. okay, I hope it is going good for you. Okay, which of the following does not show positive deviation? Which does not show positive deviation? Positive deviation means that the intermolecular forces between A and B is less than AA and BB. So means some of it is one of it is showing negative deviation. One of it is showing negative deviation. So what is that? That is benzene and chloroform. Benzene and chloroform. Okay, that is benzene and chloroform. Because due to the pi electron cloud of benzene, there is dipole-induced dipole interactions between them. There is dipole-induced dipole interactions between them. Okay, why? Because of the pi electron cloud of benzene. Benzene acetone, one is polar, one is non-polar. Obviously it will show positive deviation. They have very weak intermolecular forces. Again, polar ethanol, non-polar benzene, it do hydrogen bonding. It will disrupt the hydrogen bonding. Benzene carbon tetrachloride, also we have dipole-dipole interactions in carbon tetrachloride. Okay, and if you even if you mix them, the interactions are very weak. So all of these show positive deviation. All of these show positive deviation from Raoult's law. Only this show negative. Why? Because of the pi electron cloud of benzene. Okay, we get in chloroform dipole-induced dipole interactions happen. Okay, next question. Active mass. Okay, so one thing before you start the question, active mass is equals to the molarity. Active mass equals to molarity. Okay, active mass is nothing but molarity. So 6% solution. What are we given? We are given 6% of solution. 6% of solution means 6 gram of solute is dissolved in 100 ml of solution. Okay, 6 gram of solute dissolved in 100 ml of solution, and if active mass is 2, that means molarity is 2m. Active mass means molarity, right? Okay, the molecular weight you need to find. Amount of solute is given, molecular weight you need to find, volume of solution is also given, molarity is also given. Simple, we have all the data we need. Molarity, what is molarity equal to? Number of moles of solute present in 1 liter of solution, right? What is the number of moles? 6 upon, we don't know the molecular weight, we need to find that value, right? Molecular weight times volume of solution is 100 ml, we'll convert it into liter. Molarity is what? 2. Molarity is what? 2. So if you calculate it, it will come out to be 30. If if I'm correct. Yes, it will come out to be 30. The molecular weight is 30. Simple, easy, yes, efficient. But you do need to know what is active mass. What do you mean by active mass? And what you're talking about 6% solution. So if you're talking about molarity, then this 6% means 6 gram of solute dissolved in 100 ml of solution. Okay. Next question. Boils at a temperature more than the boiling point. More than the boiling point. What are we talking about here? Azeotropes, right? And minimum or maximum? Yes, we are talking about maximum boiling azeotropes. Maximum boiling azeotropes. Okay, so one thing you should know actually that your maximum boiling azeotropes, we have two type of deviation, positive deviation and negative deviation. So when you have positive deviation, the solutions will make a minimum boiling azeotrope. Minimum boiling azeotrope. And when you have a negative deviation, from Raoult's law, we'll get a maximum boiling azeotrope. Nothing against it, okay? What is the reason? Simple reason. When boiling point is what, at which point the vapor pressure become equal to the atmospheric pressure, right? But if it is a negative boiling azeotrope, that means the intermolecular forces are really strong. So you need to heat it to a higher temperature to break those bonds, to break those strong intermolecular forces. So that is a maximum boiling azeotrope. Similarly, if positive is there, that means already the vapor pressure is low. You need to heat it to a very low temperature, and even at that temperature, the boiling point will, that liquid will boil. Okay, so lesser temperature you are heating, that means a minimum boiling azeotrope. So if you are mixing and you are getting more than the boiling point of either of them, that means it is showing negative deviation from Raoult's law. It is showing negative deviation from Raoult's law. Just write it down somewhere. It's a trick. If you have positive deviation from Raoult's law, minimum boiling azeotropes are formed. If you have negative deviation from Raoult's law, maximum boiling azeotropes are formed. Last question. Okay, now the last question is equivalent weight of KMnO4 is equal to. Okay, very simple. Yeah, it will be, we don't know the molecular weight, it's not asked. So for KMnO4, I know one thing, that MnO4 negative, right? I can write it. Okay, it gets converted into Mn2 positive. It gains how much electron? What is the oxidation state here? X minus 8 equals to -1, so it is +7. Here it is +2. That means it gained 5 electrons. Okay, if you want to write the complete, then it will be 4H2O. Yes, it will be 8H positive, right? The balancing is not there. You just need to know that if you have MnO4 negative, it gets converted into Mn2 positive. And how many electrons it gains? 5 electrons. It gains 5 electrons. And in this case, equivalent weight will be equal to the molecular weight divided by the N factor. For redox reaction, okay, for these kind of redox reactions, right? Reduction or oxidation is happening. This N factor is equals to the number of electrons involved. Number of electrons involved. In this case, how many electrons are involved? 5. How many electrons are involved? MnO4 negative getting converted into Mn2 positive, right? So how many electrons are involved? 5. Okay, so that means the equivalent weight equals to 1/5 of molecular weight, 1/5 of its molecular weight. Clear? Yes. Okay. Yep, that's all. And if you really enjoy the session, do give it a like. And my dear students, be ready. Okay, COMEDK is coming really soon, and obviously we all are here to help you. Take care. All the best.